So let's talk about how we can actually create container and release them essentially through GitHub. So Dave talked a little bit about this morning about Docker, being able to create Docker container with a Docker file. You can do this on your computer. You just need to install Docker desktop and Docker on your computer to do it. But one of the most efficient way, especially if you're using GitHub, is to actually create Github Actions to do this automatically for you. So what I'm going to do in this demo is go through essentially the three pieces that you need to work on to be able to do that for your own repository. And I'm going to use this particular repository as an example. So that's going to be the first part of what we're doing. And then the second part, I'll go into using myBinder directly. Just know that the technology under it, repo to Docker, essentially is what's being used here both times. All right, so to get started with Docker containers, what you need to do, the first thing is to create an environment file in Python or requirements.txt if you're using pip. I highly recommend you use conda and environment.yaml, has more flexibility. If you're interested in kind of looking at the difference between the two, there's quite a bit of information on the LeapFrogs platform. So what does an environmental file look like and does? Essentially, it gives you the name of the environment and what are the dependencies that your code needs to run. So the little notebook that I showed really depends on this particular platform package called paleoclim that you can install through pip. So because you're actually creating an Anaconda Conda environment, the first thing you need to say is which Python do I need? And I need to install pip so that I can pip install this package called paleoclim. And then because you want to have people being able to interact with your notebook, you also need to install Jupyter and either Jupyter Lab or Jupyter Notebook inside the container so that they can open it and actually use it. So what packages needs to go into the dependencies? How you do this? Do you need to pin version? Things like this. That gets a little bit more in the art than the science. But in general rules here, the more packages you put in and the more you pin the versions of those packages, the harder it is going to be to create the environment because you might end up in a situation where you have conflicts between the versions that you're asking for. So one of the best thing to do is if you have a main package like the one that we're using here, paleoclim, is to look at its at what actually requires from that package. So let me show you what the requirements are. For this particular package, you'll find it in setup.py. And you can see that it actually requires quite a bit of the Python libraries like pandas, seaborn, and so on and so forth, with some pinning already. So in this case, I would strongly encourage you to just install paleoclim and let's essentially the version of paleoclim dictate what gets installed rather than trying to constrain every single library to a particular version. And if you need to pin paleoclim because you really are working with a code that you don't think you'll be seeing for another 3-4 years, then I would probably pin that package and actually work with it. So that's your first thing, is to actually create that environment.yaml file and put it onto your GitHub repo. And you can create this with any like editor. I tend to use VS Code for this because it has a nice YAML editor, but you can create with anything you want. So that's your first step, is to get the environment file. The second step is to actually kind of think about where you want your container to end up. There are many hubs out there. The one that you might be more familiar with is Docker Hub. But for science application, I strongly recommend using Quay.io. It has more capabilities, and also if you're creating public repositories, then it's unlimited download, upload, things like this. So the first thing you need to do is, well, log in, create an account, log in, and then once you get to your account, you can actually create a new repository. So here, what you do is give the name. Again, it has to be unique, like of what you are doing on GitHub. And then you can actually choose whether or not to put it public or private. Just know that if you're putting things private, you're a little bit more limited in terms of what you can do, but also in terms of what Quay allows you to do for free. But since the goal is to actually share your science, I strongly suggest you put it public from the get-go. So now that you have your repository, so I created one a while back for the core visualization. Let's have a look at it. And here you can actually look at the different tags. So basically think about it as being version of the code that gets essentially containerized every single time that something happened in GitHub. And we'll talk about this in a second. But so basically there is a history of the different version of my software that you can actually refer to. So let's say you have something, from like 10 years ago that, well, maybe not 10, but like 5 years ago that needs to be run again, but you really want to use the version from 5 years ago to make sure you can reproduce the results in the paper, you could actually go and grab that container. That's really what it's for. It also shows you the different history of tags, different builds, the usage log, so who is actually pushing and pulling your repository, so you get an idea of how much it's used, and then different settings. So the first thing you have to do when you want to actually link your GitHub account to Quay is actually create a robot account so that Quay and GitHub can actually communicate with each other. So the way to do this is to actually select a user, say create robot account, and essentially it's asking you to give it a name and give it something memorable so that you actually remember why you created this. And then you can provide additional description. Once you've done this, make sure it has write access because it needs to actually be able to get the container from GitHub and write it onto Quay. And at the end of the day, when you're done with it, it's going to actually show up here as core visualization image builder because that's how I called it. So I am not going to click on it because otherwise you'll have access to my password. But essentially, if you do, you'll have 2 lines. The first one is the name of the account, and the second is essentially the password and the key. So make sure you save this in a safe place because you're going to actually need it for enabling GitHub to work with Quay. So once this is set up, your next action is to actually put that username and that password in GitHub. So go back to your repository, go to settings, and in settings, you can create secrets and variables, do actions, and you'll see you can create new repository secrets. And I think I'm on the paleoclim one, so let me go back to visualization one, but it's going to be the same thing. Actions. And essentially, you want to name those actions. So I name them Quay password and Quay username, just because I have a template for the GitHub action files that it's going to be working under. But here you enter the first line of, if you click here, the first line that is being shown to you. And then for the password, it's the second line. And so you basically create the name, Quay password. Let me show you quickly what happens. So put the secret name here. So here would be Quay password, for example, and then we just copy paste that key into GitHub. And that will essentially give permission to GitHub to push the Quay. So now how do I create the containers automatically? So what you want to use is something called GitHub Actions that allows you to build, automate, and deploy different pipelines directly from GitHub to another platform. In this case, we're going to push to Quay or to do things like testing your code, things like this, many GitHub actions. So if you go to actions, for you, it might look a little bit different. If you don't already have a workflow here, it will actually show you a page. It's going to look more like this, where you can choose what kind of workflow you want to do. And you have templates that you can use. I tend to actually look at other people's repo who's done something similar what I'm trying to do, and then just say, I'm going to set it up for myself and copy paste kind of what they've done. Other good places to get workflow ideas, like inspiration, is also GitHub documentation itself. But if I click on this, I can set up a new workflow, give it a name, and essentially commit it later on. So let's have a look at the one that we have for that container. It's called build container image. If I go to the YAML file, this is what you would want to copy paste for your own purposes. But essentially, it contains few information. So name is just the name of the action. On means when do you want this action, so this workflow to start? Like what kind of actions will trigger it? So if you run things like, for example, you want to test your code every time you make changes, you might want to do something on push or pull request, things like this. In this case, because we're interested in containers, the only thing you really want is when you do a release. So this is basically why I have two things here, which is on release. Every time I release, that action is going to get triggered. And on workflow dispatch, what that means is that I can go, and I'll show you right after this, I can go into my workflows and launch them manually. I tend to do this in case, let's say you do a release and everything in your release works fantastic, but then for some reason there was a problem with the workflow that created um, the container. You don't want to do another release, right? So you can just fix whatever the problem is here and manually trigger it to create the container. And then essentially what jobs is a description of the workflow. So basically each of the steps, it's kind of like a scientific workflow, which each of the steps that needs to be done to do the action that you want automatically. So in this case, what I'm telling it is run on a Linux machine. And there's two steps. The first one is to check out the files in the repo. So basically says grab all my files in my repo, including my environment.yaml file, and put them in that virtual environment for a little while. And then what I want to do is basically use repo to Docker to create my image. And again, there are many different actions. You can actually look at them. I think in the Leapfrog platform, I give you a link to go see which one are available. But that's all you have to do. You don't have to write any code. You just have to say, I want to use this particular action on my main branch. And then again, because you need to push to Quay, this is where that username and password is actually coming in, and what the name of the image for Quay. So if you look at it, that name is essentially the name of my repository on Quay. So if you do this, and assuming your environment file is working and everything is working well, this is how you get your Docker container. And then people can actually pull it. So you can fetch it. Let's say I want to fetch through a Docker pull. So people can actually pull it and play with it. If they want a previous version of it, they just have to give the tag name here instead of latest. So that's how, at a high level, you create a Docker container using GitHub Actions. Another way to share your workflows that makes it a little bit easier for other people to reuse is Binder. So the problem with containers is you can create them, but then the person on the other end of what you're sharing needs to actually understand how to use them and how to open the Jupyter notebook within that environment. So not necessarily the easiest thing to do. And so what you really want is for somebody to be able to have that environment created for them, and all they have to do is look at your notebook. And this is what myBinder allows to do. So all you have to do, it's actually very simple. It's using, again, the same repo to Docker information. Repo to Docker library to actually build a container and serve it essentially in the cloud on their server. So all you have to do is give the image, like your repository URL, tell it it's at the head, so the main, and then basically say launch. I'm not going to do this because it can take quite a bit of time to actually build it. You can do it on your own if you want with your own repository. But at the very least, and if your environment file is working properly, you should actually be able to access it, and then you should make sure that it runs for you for your environment. So the problem with this, and this is why I'm not launching it, is because depending on your image, it could take a few, like 10, 20, 30 minutes to build. And so it's not necessarily the easiest, fastest way of sharing something. So what you can also do with Binder is cache essentially an image somewhere on your, like on Quay, for example, of the container. And instead of rebuilding the container every single time, it's going to go and fetch the one that's already done. Two advantages to this. First of all, it's faster. But second of all, because it's not rebuilding from your environment.yaml file, it's even when things are going to get older and it won't be able to rebuild as easily, it will still work if it's already in an image in a container. So to do that, all you have to do is create a binder folder onto your repository, click on it, and then you need two files in there, a Docker file and a config.json. So the config.json is actually optional. It's just basically giving you the image that is built. So it's more like later on if you want to remember what is actually being built and what it's actually using under the hood, then you remember your image is on Quay. So it's more for you or for somebody to indicate where the image is being fetched. The Docker file is really what myBinder is using to build the image from that container, or just serve the image from that container. And all you have to do is say from that repository on Quay, set the working directory, copy the file into the container, and then just say, I want Jupyter Lab, open the port. And essentially what's going to happen is Binder is going to go grab this, and it's going to actually be much faster to build. And I'm going to stop the recording and take questions.